In this video, I'm going to show you everything you need to know about using Docker Compose in your .NET applications. We're going to code this literally from scratch, starting from an empty Docker Compose file, adding our first service. We're going to talk about images, containers, networks, environment variables, and everything else you need to know. Let me first walk you through our sample application that has one external dependency for now, and that is a Postgres database. And it's just a .NET 10 API exposing a couple of endpoints through minimal APIs. And here you can see a couple of CRUD endpoints for creating, reading, updating, and deleting products from our database. Now, what we are missing is the database instance, and I'm going to show you how we can easily manage this on our local machines using Docker Compose. So my recommended way of getting started with Docker Compose is through Visual Studio, where you can right-click your API project, then you're going to go to Add, and you're looking for Container Compose support. You may also want to explore a modern variant, which is using Aspire as an orchestrator. However, using Docker Compose is the more low-level solution, so I think it's critically important to know this in order to know how to work with Docker images, containers, and local orchestration using Docker Compose. So from this menu here, we first get to pick which operating system we want to use, and I'll be using Linux as it's more lightweight and hosting options for this are a lot more affordable. Then we can choose our container build type. We can say we want to have a Docker file, and here we're going to configure how we're going to build our API into a Docker image. You can think of this as a template that allows us to initialize a container, which is a running instance of our image. The next thing is choosing a default image distribution, and right now I want to use Alpine. This will give us a lower memory footprint and our final image sizes will be smaller. So once I'm happy with this, I'm going to click OK, and this is now going to scaffold a couple of files into our solution. And let me create a solution folder that I'll call source. We're going to move our API in there. And then let me show you what was scaffolded. First, inside of the products API, we now have a Docker file, which is what we use to define our Docker image. I always recommend learning about the basics of how Docker images are defined, but for our baseline understanding, you should know that we are starting from a base image, and we said we wanted to use a more lightweight Alpine image. We still have to use the .NET SDK to actually build our project, which is this part here. But finally, we're going to publish it and then run it using our ASP.NET Core image. Another thing we configure here is which ports are going to be exposed by this image, and those are going to be 8080 and 8081 for HTTP and HTTPS respectively. So that's our Docker file. It's what we use to define our image and then run our application inside of a container. And the second thing, which is what we came here for, is the Docker Compose file, and we're going to start from this minimal file that defines our services. So this is the top level section, and then our first and only service for now is the products API. We're using a local image and defining the build context, which is just pointing to our Docker file. So then let's see how we can customize this. For example, I can define which port I want to expose to my local system. And this is one of the first things you have to understand. Ports that we exposed inside of the image definition are internal to the container itself. And when we map these ports, we are essentially mapping the internal container port, which are 8080 and 8081, to localhost ports of, in this case, 5000 and 5001, which is where you'll be able to reach your API instance. Now, let's define our first service, and I'm going to call this the products database. So this is going to be our Postgres instance, and we have to start by defining which image we want to use. You can find Docker images for almost any service you want to run on Docker Hub, which is the default option. There are also other container registries that you're going to run into, but Docker Hub is going to be the most common one. And to run a Postgres database as a container, we specify an image called Postgres. Additionally, we can specify a version, let's say 18, which is the latest one, and we can also use an Alpine image. So I can say Alpine 18, and this is going to run a more lightweight image of Postgres. Although the correct name is 18 and then appending Alpine, but I think you get the gist. Then I can also provide a custom container name if we want to call this locally with some other name, and we can also do the same for our API instance. Now this allows you to use uppercase, for example, if you want to. You can also just call this the API, but I'm going to revert to my service name because I find it simpler. Then if we want to pass in some environment variables, we can specify the environment section in this YAML document, and then we can start setting things like the Postgres database, which is going to be initialized when we start the container instance. Then I can also say the default username and password of, let's say, Postgres, and Postgres for the password. The environment variable name is Postgres password, and let's give it a value. But you also don't have to hard code these. You can pass them in as environment variables, and the simplest way is through an environment file. So I'll say new item, and I'm going to call this a .env, and inside of here I can just define some key value pairs that are going to represent my environment variables. So I can have a database variable, a user, and a password. And how I reference these inside of my Docker Compose YAML file is through a dollar and then curly braces, and then you specify the name of your environment variable. So now I can pass these as environment variables, and I no longer have to hard code them. It's also a common practice to add this to your git ignore file so that it never enters your version control system. Then another thing you can do is, in the case of a database or any other container that can store some data, is map a volume. Now you can use a named volume, which is going to be managed by Docker on your system, or you can use a mapping to map this to a local file on your system. So let's say I map this to a folder called containers/database, and then I need to define my internal folder, which is going to depend on the specific image. But in case of Postgres 18, I should use var_lib/PostgreSQL. This means that if my application restarts, my data won't be lost because I'm storing it on my local file system. I can also expose the ports for Postgres. The default is 5432. And then some other things you can do which are quite interesting is expose things like health checks. This is how I can expose a health check for my Postgres container. And what this allows me to do is to tell my API that it should wait for the Postgres container to become available. This is going to prevent a common set of problems where your API starts faster than your database, and maybe it tries to perform some migrations and then it crashes because the database isn't available, and adding a simple health check solves this problem. Now you need to tell your API service to depend on your products database. So I'll say depends on, and then specify the service name, which is this part here, and then we can specify the condition, and you have a couple of options to choose from, like service started, service healthy, or service completed successfully. I'll use service healthy, and this requires you to have a health check defined on your dependent service. Another thing we can do is define our environment variables here, and for example, this can be your database connection string. Now you have to use connection strings and then a double underscore to match the format inside of app settings JSON. So here we would say connection strings, and then we would have database here with the respective value inside. And if we want to match this inside of our Docker Compose file, we're going to say connection strings, double underscore, and then database. And then the value for this is going to look something like this. And notice that for the host value, I'm using products database, which is again the service name inside of my Docker Compose YAML file. So I can depend on the service name, and Docker knows how to resolve this to the correct address inside of the Docker network. And this is another thing you need to wrap your head around. The containers running inside of Docker Compose are going to have their own internal network, and they are allowed to reference each other, which is why we can use a service name here to kind of facilitate service discovery and not have to hard code the actual address. The port is going to be the internal port, not the one you mapped externally. So if you change the external port to 6432, your connection string doesn't change because it's connecting to the Postgres instance, which is running within the same network in a container. The default database username and password, those I can pass in as environment variables, and suddenly we have a pretty decent setup inside of our Docker Compose file. Another thing you can configure for your containers is the restart policy. So let's say I always want the API to restart in case it runs into some problems. And then one more thing I mentioned is networks, and this is also something that we can configure inside of our Docker Compose file. So I can define a network section here, and let's just create a default network, which I'm going to call bridge. For our network, we have to decide which driver we want to use, and the default one is bridge. I recommend taking a look at the documentation to learn what are the other types of networks. For the most part, you won't really have to think about this. You can omit this section and just fall back to the default option, which is bridge, or you can define your network explicitly, and then you can tell your services that they are part of a specific network by defining the network section under each service. So let's tell both of them that they are part of our default network. And now I think we can run this, and you'll notice that the startup project is now Docker Compose. This is another thing that is set up when we scaffolded the Docker Compose file, and this gives us a very easy way to debug this through Visual Studio. So if I start this and we open up Docker Desktop, you can see we have two services up and running, our API instance exposed on the correct ports, as well as our database instance. My API is configured to start the Swagger UI page when it loads, and you can see this is available on localhost 5001. And let's just test this out by trying to create a product. You can see we get a response back. Let's fetch a product with the ID of 1. This also works. I should also be able to update my product. Let's set the price to 1, 2, and 3. And if I fetch this through the all products endpoint, you can see this uses pagination. We get the updated product instance. And finally, we can also delete this. So just going through all the CRUD endpoints, you can see this succeeds. So, and just to make sure that this is deleted, let's try to fetch this. And as expected, we get 404 not found. You can confirm all of this is working as expected by taking a look at your logs inside of your Docker container, and you can see our select statement here, you can see our delete statement here. We can also find the update, and somewhere over here should be our insert. So logging is working just fine. We can also go into the logs for our database and see if there's anything interesting there. And this covers a lot of the baseline setup, as well as some more advanced scenarios like health checks and properly defining dependencies, and also even passing in connection strings that depend on your other services. Now, say we want to extend this by adding another service. So for example, let's say we want to use Redis as a cache. I can now define a product's cache service. For the image, let's use something like Redis 8 Alpine. Let's say I want to always restart this in case of failures. For the ports, let's expose the default port, which is 6379. I want to map this to the same value internally. I also want this to be a part of my network, so we'll say networks, and then we're going to say default. And then another thing you can do, which is a more advanced option, is pass in a command to your container instance when it's starting up. So I can pass in a command saying Redis server require pass, and this is going to require any client application connecting to my Redis server to pass in a valid password. And as you may have guessed, we're going to pass in this value through an environment variable. So let's define this inside of our env file. So it can look something like this. We're going to pass this value to our container instance, and it's going to require a password for any service trying to connect to it. Now, much the same as the database, we can also define our dependency on the cache service. So let's say the API depends on the cache, but we can make the condition more loose, and we can just say that we need the service to be started for our API to also begin running. Of course, I'm also going to pass in the connection string through an environment variable. So we'll say connection strings and then cache, and then I can pass in the connection string value, which is going to point to the product's cache service, the internal port, which is 6379, and we're also going to pass in the password using the environment variable. So we've defined our service, but we have to actually use it inside of our API. So let me just give you a quick demo of that. I'm going to add a NuGet package into my products API. Let me look for Microsoft Extensions, Caching, Stack Exchange, Redis. I will install the latest version. And then with this library installed, we can say builder services add Stack Exchange Redis cache, and this expects a connection string. So we're going to say options, and then in the options we're going to set the configuration value, and we'll get this by saying builder configuration get connection string, and we're looking for a connection string called cache, which we are setting inside of our Docker Compose YAML file. And finally, let's use this inside of our get endpoint for fetching a single product. So we're going to go from this implementation to this one. It uses an iDistributed cache, which is going to connect to our Redis instance, and we've got a getAsync method, which is going to implement the cache aside pattern. So let's start this. And when we open Docker Desktop, you can see that under our Compose stack, we also have a Redis instance up and running. And to test out if this is working as expected, I'll create a product that has the ID of 2, and I'll try to fetch this product. And on the backend, I place a breakpoint inside of our endpoint and also the factory function. So if I send this request, we're going to immediately hit the breakpoint. If I press continue, we'll execute the factory function and we'll get the response in the Swagger UI. And if I execute this again and press continue here, we will not hit the breakpoint because this value is cached inside of Redis, and you can see we get the response served back to our Swagger UI client. From here, you can continue building on your Docker Compose setup, and I showed you a lot of the basics like how to map ports, what are internal and external ports, how to set connection string values, which host values you should be using, for example, referencing the internal service names and relying on the Compose service discovery to resolve this to the correct address, dependencies and health checks, networks, mapping volumes, passing in environment variables. So you should be ready to get started. And of course, if you want to grab the source code for this, it's going to be available for free from the pinned comment right under this video. And if you want to see how you can take this further and even get rid of a Docker file to build your .NET application into an image, I highly recommend taking a look at this video next, which shows you how we can use the .NET SDK to build a Docker image. If you enjoyed this video, consider gently tapping on the like button. Thanks a lot for watching, and until next time, stay awesome.